In matching code, the format is that in a certain positions of a bit pattern, different information is written. A particular set of bits specify an operation, the other ones the value of the operand in which you apply the operation, so on and so forth. These long bit patterns are prone to be mistaken or swapped by human programmers. These are replaced in assembly programming language by mnemonics. A mnemonic each small set of letters representing a processor instruction that is called also opcode. Thus, the programmer doesn't need to know the binary form of instructions, just the mnemonic. Also, some hardware registers in the processor have a name rather than a binary code as identifier. Sections of the program, as well as data, can be named, reducing the usage of binary expressions. That will make the program more readable and understandable. Registers are small pieces of inner memory within processors. Bear in mind, processors manipulate data and do operations upon operands, so they need to handle this data and the results from within. So they need space to keep this data while it's being processed. These registers are not normal memory space. They're inside the processor and are reserved to be used by the ongoing processes that the processor executes. Anyways, these mnemonics and names have to be translated to plain binary code. This is done by a software called assembler. Every individual line of instruction is translated to its original value in binary. It's almost directly converted from a mnemonic to binary code, which makes the assembly language a fast and space-saving code, just like if it was written in matching code, but a lot more easy and fast to be written by the programmer. This language is still low level, and since it uses bare processor instructions, a program written for a different processor will not work. You'll have to make changes or redo it from scratch. Every processor has different hardware design, as assembly programs manipulate inner registers to accomplish instructions, and these ones may vary from one to other. A different processor needs different code, so this language code are not portable. Okay, so now let's do a review of an actual piece of assembly code. Just as I told you, binary codes have been replaced by these mnemonics, which are sets of small letters representing the name of the processor instruction that we are applying. So this one, ST, stands for store, which has two operands, the value and the address in memory in which you'll store this value. So store 1 in the position 801, this other one is store 0 in the position of 802. In these columns we have the labels, which are names that you give to a particular piece of instructions in your program. So you can do control of the flow of instructions. Let's have a look. The first instruction of this top section is branch if equal. This instruction basically compares this value, the second value, to the value stored in this position. So if 802 is equal to 10, then jump to BOT. So it will jump, it will go to this section of your program. Otherwise, it will increment, actually it's going to execute the next instructions that we have here. So the next one is increment the value of 802. Increment means increment by 1. So the value of 802 was 0, so it's incremented to 1. The next instruction is multiply. Multiply what? Multiply this value in 801, which is 1, by 2, and place the result in 803. So it's going to be 1, 1 multiplied by 2, it's equals to 2, and see what we do here. Store the value, store the value of 803 into 801. So we couldn't do the multiplication and store the result in this register, because it was in this space of memory, because it was the operand. So it requires 3 operands, and we have to store the result here. But we want it to be in 801, so we have to do those 2 operations. Sorry, just to accomplish this the result in the way we want it. So pay much attention to this, because sometimes one logical instruction requires several hardware instructions to get the result you need. The next instruction is jump, which is JMP, jump to top. So it will jump to this line in your code, and it will repeat it and repeat it over and over until, of course, the actual value of 802 has been incremented and reached the value of 10. Then it will jump to BOT, which actually does this operation, takes the value of in 801, loads it into register A. This LD stands for load. It will load the value of this position in memory to this register, and will call the subroutine print. So print basically will be something like outputting your this number into your screen, basically. Uncall is an instruction that calls another function which is sometimes more complex, has much more instruction than these ones. So you basically take this result and call the function print to handle this task of outputting this result in your screen. So this is a let's just summarize this thing. We start with the values of 0 for 802 and 1 for 801. And we start incrementing 802 to 1, 2, 3, 4, 5 until it reaches the value of 10 that will lead us to this position and will end the program, okay? But bear in mind that every time we increment 802, we also multiply the value of 801 by 2. That started at 1, 2, 4, 8, so on and so forth. And we store the result back every time in the same 801. So it's basically what it does. So we have already reviewed, we used mnemonics, which are short text forms of these binary instructions. These are translated from the source code, that is the program, using those particular instructions in this language. It's translated by the assembler to binary code, which is also called object code, and will be loaded in a particular processor or computer by the loader. But remember that it has a unique set of instructions of this particular microprocessor or this computer. So if you want to change it, you have to change some instructions depending on how many registers, how the other processor does this operations, and that's why it's called non-portable. Okay, this is a much larger demonstration of an assembly code. Let's have a look here. It says page 2, so it's not the entire code. This is just one single part, and this one is other feature that we have in assembly language, in assemblers. This one is the comment section, which is made with asterisk, and you just input text that is an explanatory text of what of the parts of your code. What does this part of this code? So it says it is a function called init a, its function is to initialization, initialization, sorry. Input. It takes no data input to be processed here, nor does this produce any result that is going to be output to be used by other parts of the program. And its effects, does it call any other subroutine or functions? No, it does not. It does all the job itself. And see here, there's we may call it as constants. You gave them a name and say this expression equals this numeric value in binary, and you can call it from there on other parts of your program. So have a look at this. You say LDA, which is loading A or something, the value of reset A, which is this. So you can kind of give them these values an alias, and you have some other facilities to make this code more readable. However, remember it's low level and it still needs to be translated from your mnemonics, your assembly language, to this binary equivalent, just like any other programming language. So that's all there is to assembly language.